Welcome back to another video. In previous videos, we talked about how structural models can be combined with economic theory to estimate so-called deep parameters or economic fundamentals. These include things like preferences or technology or information. In this next set of videos, we're going to discuss how economists estimate preferences using data on observed choices and characteristics about the choice setting. We aim to quantify people's preferences using data on the decisions that were made. This concept is actually deeply philosophical. How can someone know what your true preferences are if they can't read your mind? The answer is that they can tell from what you've chosen given what was available. This is what economists call revealed preference theory, and it has deep application to almost every field of empirical economics. Today, we're going to introduce the basic statistical framework through which we can actually use data on observed choices to make some inference about preferences. It's helpful to go through an example. We can think about your decision to choose where you want to eat tonight. Suppose there's 5 different restaurants. You walk past 4 of them and you decide that you want to eat Thai food. By entering the Thai restaurant, you've told the data analyst that given your current mood and the prices at the restaurants and the weather and everything else about tonight, going to eat Thai food maximizes your utility. Some factors driving your choice might be observable. We can see the menu prices at the restaurant. We can see how far the restaurant is from your house. Maybe the Thai place was running a special that had lower prices than the other restaurants. Other factors influencing your choice are unobservable to anybody but yourself. These could be the mood that you're in, or if you're craving a particular dish, or maybe you speak Thai and you want to get some extra practice in tonight by speaking with the wait staff. What matters is that the choice itself reveals your preferences given the circumstances of tonight. Because there are both observable and unobservable components to your decision, sometimes you'll hear these type of models called random utility models because there's a random or unobservable component to the decision. Let's formalize this by reviewing some slides. Mathematically, we can assign these 2 different components of your utility to a variable called capital U. So capital U is going to be different for each decision maker I and each choice option J. And it's going to be composed of observable components, little u, and unobservable components, epsilon. Little u is going to capture anything about the choice or the decision maker that we can see. Maybe it's the price of the product or how far away it is in travel time, what the rating is of the restaurant. And it could also be characteristics about the decision maker. How tall is this person? What kind of food have they eaten in the past? These types of things. Then we can also think about what is unobservable to the analyst, but observable to the decision maker. So the decision maker sees both little u and epsilon. The analyst analyzing the data only sees little u. And epsilon includes things like what mood you're in, or if you're craving a particular dish, anything we can't measure. It could also be things about the restaurant that we can't see, like how friendly is the service staff and so forth. And if we just think about how we could use the information in U to actually come up with a number for your utility, well, we could think about maybe the price and the Yelp rating and the travel time entering linearly and having some parameter values associated with them. But then we have epsilon, which might just be a positive scalar number that says, well, I really am in the mood for Thai food. And then when making the decision maker is combining little u and epsilon. And by definition of revealed preference, or the utility maximization principle, we are going to assume that the decision maker maximized their utility if and only if it was the highest utility available out of all the options. So this is just a mathematical way of saying that the one that we saw chosen was the highest utility, even if we can't see all the aspects of utility because of the epsilons. So we can write this in terms of capital U, or we can write it in terms of little u plus epsilon. And since we data analysts don't observe the epsilons, we have to think probabilistically about the choice. So instead of saying, given your characteristics and the characteristics of the restaurants that we're looking at, I know for a fact that you're going to choose the tire place. We as the data analyst can't say anything about that because we don't have all the information that the decision maker has, because some of the information that the decision maker has is in epsilon, which we can't see in our data set, or we're not choosing to include in our model. So if we were thinking about how to conceptualize this probability, we would say if we reset the epsilon and we took 100 different draws from epsilon, how many times out of 100 would we expect this person to have chosen to eat at the Thai restaurant? Now that we've kind of understood the utility maximization principle, it's helpful to think about what the properties of the choice set needs to be. Now, the choice set is the set of available options given this particular decision point. The choice set has to be finite, which just means that there can't be an infinite number of restaurants to choose from. This is where we get the word discrete from discrete choice models. The choices also have to be mutually exclusive, which just means for our purposes, you can only choose to eat at one restaurant. And then the choice set also needs to be exhaustive, meaning that these are all the realistic options that were available to you. These properties are not overly restrictive. We can always redefine things to satisfy these properties in a way that would still preserve the realistic nature of our data. So for example, maybe you're worried about the exhaustive property and saying, oh, well, there's actually 25 restaurants in the city and we're only looking at 5 of them. Well, we could redefine a 6th option to just be any other restaurant, and then that would preserve the exhaustive nature of the choice set. We could also think about eating at home as another option. So then we could add a 7th option that was eating at home. So we can always redefine things so that the choice set satisfies these criteria, but these are the criteria that we need in order to have a mathematical foundation to infer preferences from data on choices that were made. So this is what really drove me to my dissertation research in graduate school, and something that I really enjoy thinking about and discussing. And so that's part of the inspiration to make this video series, is to share these ideas with the world more broadly. There's really a profound elegance in being able to take data on choices and then infer what people's preferences are, and then use those preferences in some counterfactual setting to predict what might happen to a policy that's hypothetical in nature or that we haven't ever considered before. The other nice thing about these random utility models or discrete choice models is that we can use them to put a value on how the consumer values different attributes about the choice. What I mean by that is we can say, okay, well, if this consumer is price sensitive to this amount, then I know how much he or she is willing to pay to get a higher level of quality or to go to a restaurant that's closer to home, and so forth. And the beauty is that we can get all this just from looking at observed choices. We don't have to ask each individual consumer, how would you rank these options, or how would you value this attribute relative to another? That's it for this video. In the next video, we'll talk about why only differences in utility matter, and we'll derive our first discrete choice model.